Hi everyone, welcome back to my channel. I am Dr. Shahbaz here. So in this video, we will learn how to perform and interpret a paired sample t-test in R. A paired sample t-test, also called a dependent sample t-test, is used to compare the means of two related measurements. For example, we may compare participants' scores before and after training, health scores before and after treatment, or the same individual responses under two different conditions. Unlike an independent sample t-test, the two sets of observations in a paired sample t-test come from the same participants or from appropriately matched pairs. So in this case, the null hypothesis states that the mean difference between the two measurements is zero. In other words, there is no statistically significant change. The alternative hypothesis states that the mean difference is not zero, indicating a statistically significant change. So the main assumption we will also test before conducting the paired samples t-test. So in this video, I will demonstrate how to import and examine the paired dataset, check the assumptions, calculate descriptive statistics, conduct the paired samples t-test, interpret the statistical findings, conduct the effect size, present and save the results in the end. So please watch the video until the end. If you find it helpful, like the video, subscribe to my channel and turn on notifications for upcoming videos on our dataset. So first of all, I give my dataset to ChatGPT and took help to create the prompt for paired sample t-test. So you can see here. And ChatGPT give us the first prompt to import the data. We copy this prompt and then go back to our R window and then paste here and then press enter. So you can see we will see that open dialog box where we will select the dataset in the same directory we are working and then click on open. So data has successfully opened in our R. So in this way, next we will check if there is any missing value in our dataset. So we will copy this prompt and then paste in R. Then press enter. So it means R shows that there is no missing value in our dataset. So now we will create the difference. So we will copy this prompt and then paste in R. So R successfully created the difference before and after training. So it means before training the score was 52 and after training the score was 61. So there was difference of 9. So it means you can see for all before and after scores. So next we will check the normality by using the Sparrow-Wilk test. So we will copy the prompt and then paste in R and press enter. So you will check that Sparrow-Wilk normality test, the value of Wilk equal to 0.87116 and p-value equal to 0.0676. So in this way the p-value is higher than 0.05, so it means our data is normal. So we made the assumption of normality of the data. So now we come to next. Okay, so next we will perform the descriptive statistics of our data. So we'll copy the prompt and then go to console and paste here and then press enter. So we have the descriptive statistics, like you can see here. Before training the mean is 52.5 and after training the mean is 58.48. So it means the mean score increased from before to after. As well you can see standard deviation decreased from before to after. So there is also a difference you can see. So we have performed the descriptive statistics. Now we will check the next step and we will perform the paired sample t-test. We will copy prompt and then paste here and then press enter. So we have the results of paired sample t-test. The t-value is equal to 0.11.848. degree of freedom 11, and the p-value is 1.326e07. So it means the value of p is significant. The value is less than 0.05 because there is 70 before 1. So it means we will interpret as 0.000000132. So it means the p value is less than 0.05. So it means there is a significant difference between before training score and after training. So alternative hypothesis is accepted. True mean difference is not equal to 0. So it means the difference is not 0 between before and after training. So it means that null hypothesis has been rejected and the alternative hypothesis is accepted. You can see also 95% confidence interval, the value of lower bound and upper bound, and 0 doesn't come between lower and upper bound. So it means there is a significant difference before and after training. Okay, so next we save all results in Excel. So I just make only one command for all results we need in Excel. So we will copy this command and then paste here and then press enter. So R successfully created the Excel file for all results, paired sample t-test results. You can and see here the paired sample t-test, a newly file has been created in the same directory as paired sample t-test results. So you can open it and then interpret the results as well. There is a difference of score between after and before, and then descriptive statistics, mean and standard deviation, normality test, because the value is higher than 0.05, so there is normal data, and then paired sample t-test. You can see here paired sample t-test, t-value is significant, p-value is 1.70. So it means we will write in this condition 0.0070 and then 13225. So in this way the p-value is basically lower than our significant level 0.05. So in this case we can say we reject the null hypothesis and accept the alternative hypothesis. So there is a significant difference before and after training of participants. So in this way we perform the paired sample t-test in R. So if you like my video helpful, please subscribe my channel.